In Lesson 8, Advanced Triangle Congruency, we're going to look at some of the more challenging proofs that they've asked. And, mostly they're challenging because they have multiple steps, multiple proof statements, and stuff like that. First, we're going to look at a multiple choice problem, though. In the accompanying diagram, CA is perpendicular to AB, ED is perpendicular to DF. And you can see that they already marked our right angle, so we're good with that piece. Then it tells us that ED is parallel to AB. So usually what that creates for us is that creates some sort of alternate interior angles corresponding, and in this case that's going to be right there are going to be our corresponding angles. And our last piece here is that CE is congruent to BF. Now what we're going to do with that is we've got CE, BF. So now we're not actually going to write this proof. We also have AB is congruent to ED. So now they give us a lot of information here. So what the question is asking is which one cannot be used. So what we want to do is we just want to kind of go through them and see which of our methods doesn't work. All right. So if we look at side, 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 congruent to side, 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 look at I have CE and BF. Now remember, we could do the addition postulate and do BE and get the whole side. I have AB and ED, but I don't have CA and DF. So I'm not really sure about that one, so I'm going to hold off for a second. Side angle side. Well, if I look, again, I could do my addition postulate side. I have my alternate interior angle, and then they gave me AB was congruent. So addition postulate, alternate interior, given. So therefore, side angle side does work, so we're going to get rid of that one. Angle side. Well, they gave us the right angles, my alternate interiors, and then my addition postulate. So angle, side, and then angle, side. So that one does work. And then the last one's HL. Well, if I use the addition postulate, I get the hypotenuse. They gave us one of the legs, and I have a right triangle. So I have angle, side, side, but with the right angle, it's really hypotenuse leg. So that one does work. So the only one we cannot do is side, side, side based on what we have. In the second one, we're going to do a proof where they want us to prove triangle ABC, which is our big top triangle. So I'm going to highlight that one just so that's a little bit easier for us to see. Is congruent to ADC. ADC. So now, as we look at this, they give us that both sets of opposite sides are parallel, and then they gave us angle 1 is congruent to angle 2. So we're going to start our chart here. Statement and reason. So for our first one, we'll list out all of our givens. So we've got AB is parallel to CD. We've got AD parallel to BC. That is going to be given. And they also gave us that angle 1 is congruent to angle 2. And that step's important. It might not seem important in the beginning, but it's going to come into play later on in this proof. So when they give us all these sets of opposite parallel sides, in a shape like this, that should usually be a pretty good giveaway that we're going to be looking for alternate interiors. So as I look, I see angle 1 and this angle 3 here are alternate interior. So in step 2, I have angle 1 is congruent to angle 3. And then at the same time, because they also gave us top and bottom are parallel, I'm going to put a 4 up there. So I've got angle 2 is also congruent to angle 4, and they both follow the same exact reason. Parallel lines form congruent alternate interior angles. So now I have 2 angles in each triangle that are congruent. And the fact that you might be thinking about all 4 of them being congruent will be important in a minute. Step 3, I'm going to work with the fact that if we pretended BD wasn't there, you can see our highlighters completely overlap from AEC. So we're going to have AC congruent to AC, and that's going to be our reflexive property of congruence. So now if we look at our 2 triangles, in our yellow triangle we have angle side, angle. And same thing on the bottom, we have angle, side, angle. So our two triangles are going to be congruent. So ABC is congruent to ADC, angle, side, angle. Now here's the thing. Usually we see PCTC things in these proofs. However, if we look, you can see they want us to prove that triangle ABC, the top yellow one's isosceles. Well, if you look at all our hooks, all of our angles have one hook on them. However, 1 and 4 are the base angles, but we have no statement right now that says angle 1 is congruent to angle 4. So we need to look at this part of our proof. We have angle 1 congruent to angle 2, and we have angle 2 congruent to angle 4. So if you remember, whenever you have two different angles, such as 1 and 4, that are both congruent to the same thing, we use substitution to say that our other two angles are congruent. So because both angle 1 and angle 4 are congruent to angle 2, they must be congruent to each other. So that's important because now we have the fact that angle 1 and angle 4 are congruent. Those are our congruent base angles. So now triangle ABC is isosceles, and that's because it's a triangle with two congruent base angles. And that's how we're going to finish this proof.